Alright, I'm going to go over a couple of these problems from the Charles Law worksheet that you guys had, that you guys said you were, or I heard that you guys were having problems with. So maybe if I go through a couple of these, maybe you'll understand a little bit better, okay? So, and you might hear some coughing in the background, because the girls are sitting here with me, and so we got a little bit of colds going on. So, alright, so here we go. Starting off with, we'll just do this first one here, the number 7A. So, hopefully everybody knows at this point at least the equation, right? So you've got V1 over T1 equals V2 over T2. So that's our equation we're going to use, right? So the problem here gave you all the information, right? They gave you setting up V1, V1, and okay. So V1 they gave you is 273. T1, oh, sorry. Strike that. V1 they gave you is 1.5. T1 they gave you is 273. V2 they gave you 3. And T2 they're saying we don't know. And they're telling you in the directions that all our temperatures are already in Kelvin, so you don't have to do any conversions, and the temperatures are already in liters. So you're all ready to just basically do plugging and chugging over here on your Charles Law problem. So meaning that it's just 1.5 over T1 equals V2, we have as 3, over the temperature, T2, we don't know. So now you're ready to solve. I just take the T2, cross it over, oops. So that means I'm going to have 1.5 T2. It's a little thicker pink ink than I want. Sorry. Okay. And then I'll have on the other side, that's a little better. On the other side, I'm going to have 273 times 3. So I'm going to take my calculator. I'm going to take 273 multiplied by 3. So it's 819 because you're taking and multiplying these two now. So 819. And then you're just going to have to get T2 by itself because this is like X. So you want to solve for X. So 1.5, 1.5. So T2 is equal to 819 divided by 1.5. So that's 546. And it's a temperature, so that's in kelvins. So there's your answer. Okay.
The end.
Yeah, no, not the end yet. Okay, so there's one problem that we could work through. Alright, so if we go and we do a different one.
136, 1.
Okay. Let's see. There was one on here. Like, look at number 9. I know number 9 was probably one that you had problems with, and it was the whole milliliters thing. I didn't mean to confuse anybody with milliliters. You can use, technically here, milliliters. You can use liters. It doesn't really matter as long as you're consistent. I didn't want you to have to do any conversions. If you did conversions, that's fine. But, so like on this one, again, you're using your Charles Law.
I'm not new.
So V1, T1, then you've got V2, T2. So there's all your numbers, right? And so they give you a volume of 257, so 257 goes there. And again, you can keep that as milliliters or you could change it to liters. It's completely up to you. It's just when you get your answer, it'll rather be in milliliters or it'll be in liters, depending on what you use. And then so you got your 257, and then they give you a temperature of 45. And then they give you 300 milliliters. Find the new temperature. So for this one, again, you could keep your milliliters the same, that's fine. But you do have to change your temperature, which means you have to add 273 to this. So that's going to give you 45 plus 273.
I can see that.
Can you see that? 318. Okay. Alright. And so now you can set it up like this, which is fine. So you have 257 over 318, which is equal to 300 over T2. And then you have to cross multiply, just like the last one I basically did. So I would have 257 T2, and then 300 times 318.
I can say that.
So I have 95400, and then basically divide each side by 257. So I get T2 is 371, like 0.2-ish. And that's Kelvin. And so no matter what you did, if you changed that to milliliters or not, or if you kept it milliliters or changed it to liters, you should get the same answer. Okay. Alright, now the last one I'll work through.
The end.
Not the end yet.
I have to tell you something when you're done.
Okay. Is this number 11? I know this number 11 caused some people some problems too, because it was worded a little different. Just kind of keep the problem here. A label on an aerosol can contains a warning that the can should not be heated over 140 because of the danger of explosion due to the pressure heated. Now, this first sentence here is just extra gobbledygook. So you don't even need that. Like, it's not important. The second sentence gives you all your information. So your V1, your T1, your V2, and your T2 all come from the second sentence. So, and again, the milliliter, liter thing, it doesn't matter as long as you are consistent. So, 500 milliliters
500
is your volume. And then it's going from 25 to 54. So those are your temperature changes. 25 to 54. So now you just have to do your changes. Add your 273s. 298. 54 plus 273 is 327. And so now you've got 500 over 298 over V2 over 327. And now you're just ready to cross multiply. So 298 V2 equals, cross multiply there, 500 times 327 is 1,635,00 divided side by 298. And you get like V2, I'll write it up here because I kind of ran out of room on my screen, 548. And again, your volume over here, we use milliliters, so this answer is in milliliters. So if you changed it for some reason to liters, this is the only thing. So this would be an answer, or you could have 0.548 if you changed it to liters. Either one would be an acceptable answer. And so that just kind of goes over some answers. Sorry about all the coughing. So that kind of just goes over some of the answers to help you out there with that.